Hello and welcome to Sum and Difference Identities, Part 2. I've got an example right here to get us started. It says, given that the cosine of alpha equals 12/13 and alpha is in quadrant 4, we have to find the sine of 2 times alpha. All right, first thing I'm going to do to solving this is I'm going to change this sign of 2 alphas and tackle it this way. Why don't we call the 2 alphas alpha plus alpha? Then I can use an identity to break this apart. So this would be the sine of alpha times the cosine of also alpha plus the cosine of alpha and times the sine of alpha. The nice thing is, because both angles are the same, they're both alpha, then it's alpha, 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 all the way through. So here's what we end up having to solve. So I go, well, I don't know the sine of alpha. I know what the cosine is because it says it's 12/13, so I can get that. And then over here, I know the cosine of alpha is 12/13. But really what's giving me the trouble here is I don't know the sine of alpha. How do I get it? Well, if we draw ourselves a little picture, it's actually not too bad. Okay, so here's the grid. It says here alpha is in quadrant 4. So 1, 2, 3, 4. So we're down here somewhere. Okay. And if I draw the little triangle and I use my reference angle, we know that the cosine is 12/13. So 12 would be my adjacent side. 13 would be my hypotenuse. So I'm going to use Pythagoras to get this missing side here. So I would just set it up as hypotenuse squared equals the sum of the squares of the other two sides. Now, if I worked my way through this and I solved, I would get this guy here to actually be 5. But I'm going to think of it as -5, because if you think about this, you're going from the x-axis straight down. So it's like a negative length. So then I don't even have to use the cast rule. I can just read off that the sine of alpha would be -5/13. So okay, I can put that in there. Well, now I'm ready to finish the job. Okay, these are both going to be with a denominator of 169. And what do I got? I got -60 plus another -60. So my final answer is -120/169. And that's about all there is to that example. Not too bad. All right, let's clear the screen and we'll do one more example. And in this one, we're going to try to solve the following. We have this equation here, tangent of pi minus x. We're told that this equals √3. And we're going to try to solve it for x's between -pi and +pi. Okay, so that's our little domain, and we're going to try and solve this thing. So how do we do it? Well, first thing I'm going to do here is I'm going to go and break up the difference of these two angles according to the identity for tangent. And so it is tangent of the first angle minus tangent of the second, and that's all over 1 plus tangent of the first times tangent of the second. Okay, so that's still equal to √3. So I go, okay, well, let's see if we can finish this up a little bit. If you think of your tangent graph, the tangent at pi is 0, because your tangent graph, remember, we'll just do a mini version of it here. Okay, at pi, the cycle repeats, and halfway through there's a vertical asymptote. So it kind of goes up like this, and then it comes roaring back up. And so at pi, the tangent is 0. So this is now 0 minus tan x. And on the bottom, I have 1 plus 0 times tan x. And that still equals root 3. So here's what I got. I got negative tan x over 1. So in other words, negative tan x equals root 3. Now I'm going to multiply both sides by negative 1. It's a little bit easier, I think, to look at and say, oh, so in other words, tan x has to equal negative root 3. All right, well, that makes me think of a special triangle, I know. See if we can draw it here. Special triangle that I know that involves root 3 over 1. So I'm looking at this and I think, well, the tangent of pi by 3 would give me root 3 over 1. All I got to do is make sure that it's negative. Okay, so which quadrants do I want to be in to have a tangent that's negative? Well, I want to be here, and I want to be here. So I'm going to build pi by 3 in each of these quadrants. Okay, so remember, our answers have to be between negative pi and positive pi. So this guy here, I'm not going to name it as a positive angle. I'm going to name it as a negative angle and say one of my x's is negative pi by 3. Okay, so that's not too bad. Then what about this guy over here? Well, negative pi ends right here. So I'm going to have to go the positive route. I'm going to have to go like this. So that looks like if this is 1/3 pi, this has got to be 2/3 pi. And by golly, I think I am done with that question. So I'm going to stop there, and I'm going to come back with some more exciting trig.